Welcome back from an 8-break learners. So now we're going to do the application questions again. They are still in dealing with the reactions between the metals and the oxygen. So now let's see what we have. Complete the table by providing the missing equations for the reaction between, we have iron and we also have oxygen. Iron and oxygen. So remember that iron has a chemical symbol Fe, with oxygen having a chemical symbol O, but then remember it is written as O2 because it's a diatomic molecule. So the word equation for this reaction will then be iron reacting with oxygen, reacting to form iron oxide. Now the picture to show that now, this tells us that we have 1, 2, 3, 4 atoms of iron that are going to react with 1, 2, 3 molecules of oxygen. Remember that oxygen is written as O2. So this represents one oxygen molecule. So we have 1, 2, 3 of them. Now the product that is going to be formed is going to be, the product that is going to be formed between this is going to be, let's just create a space. Remember, the purple circles are representing our oxygen. The white circles are representing our iron. So therefore, when we write the chemical compound, we'll start with the metal. So it's going to be Fe, and how many do we have of those? We have 1, 2. And then oxygen, and then we have how many? 1, 2, 3. However, this is just one molecule of iron oxide. Because there's 2 of them, it means this equation was balanced with the 2 in front of the iron oxide. So now, we then now need to write the chemical equation to show this picture and also to better show this weight equation of the reaction between iron and oxygen. So this is going to be, remember, 4. Or starting with just the general symbols, we have Fe plus O2 reacting to form Fe2O3. Then to balance the equation, remember, we need to start by start with the numbers that you have here in order to balance what you have. So we're seeing that we have 2 oxygen and then we have 3 oxygen. So we can start there to balance. In order to balance the oxygen, the 2 and the 3, the most simplest number that we can use is the 2. So that when you multiply the 2 and the 3, it gives us a 6. Then we know that now when you multiply the 3 and the 2, we can still get a 6. Remember, 2 times 3 and 3 times 2 is equals to 6. That is the commutative law. So therefore, you're going to use a 3 there. And remember, 2 times 2 is a 4. That gives us 4 oxygen. And remember again, this picture determines what we have. We have 4 iron metals, and then we have 3 oxygen molecules, and then we have 2 iron oxide molecules. Next. Now, we are given the weight equation. We need to draw a picture of that weight equation, and then lastly, write the chemical equation for that weight equation that is given to us. Remember, magnesium is that element that is found in group 2, and the ratio we know that is going to be metal to oxygen, where the M represents the metal, and in this case being magnesium. And remember, M is not a chemical symbol for magnesium. So now, the picture, we are going to have 1 magnesium reacting with 2 oxygen. So we're just going to shade them to show the difference. 2 oxygen atoms or 1 oxygen molecule to form a magnesium with the oxygen. So remember, we are shading the oxygen to show the difference of the atoms. So now, what are we seeing? Is it balanced or is it not balanced? We're seeing that we have 1 oxygen there, and then we have 2 oxygen there. And then we have 1 magnesium there, and we have 1. So the magnesium is balanced. So in order for me to be able to balance the oxygen, I need to add in another molecule. Remember, I cannot just add an oxygen. I need to add another molecule of the magnesium oxide. So I'm going to do that. Magnesium oxide, shaded. So there's 2 of them. So we now have 2 magnesium atoms on the right-hand side. Remember, this is your right-hand side. 2 magnesium atoms on the right-hand side and 2 oxygen atoms on the right-hand side. So the oxygen is balanced, which means this is still fine. I can keep that as that. Shade, shade. Now, because I have 2 magnesium atoms on the right-hand side, that means here I need to have 1, 2 magnesium atoms. So now, So now that means if I put in there another magnesium atom there, this is going to be 1 reaction. Let's just quickly fix that. So it's going to be 1 reaction reacting to form. So we have 2 magnesium atoms that are going to react with 2 molecules of oxygen that are going to form 2 molecules of magnesium oxide. So now, what do we then have as our chemical equation? Is it balanced? Yes, it is balanced. So we need to just remove that because we do have it there. So now let's balance it using the chemical symbols. We have Mg plus O2 reacting to form MgO. So magnesium atom is going to, when we're balancing this particular reaction, we're going to have, we said we need 2 there. This remains as 1, and this must be 2. So 2Mg, 2Mg, 2 oxygen, and 2 oxygen. So now that means this particular reaction or this particular ratio, it is for elements in group 1. And elements in group 2 will have the ratio of MO. Now, moving to our next question. We are given a chemical equation. We need to work backwards by drawing the picture and giving the word equation. So now let's see what we have. So the question says, complete the table by providing the missing equation for the reaction between copper and oxygen. So if copper and oxygen, I have 2 atoms of copper, 1 molecule of oxygen that are going to give me 2 molecules of copper oxide. So picture, I need to have 1, 2 copper atoms that are going to react with the oxygen molecule. Again, remember, I'm shading it there so that it can be different from the other atoms. So when they react, they are going to give me a copper oxide, and I need 2 of them because of that 2. So there needs to be another one there, and there we go. Is the equation balanced? Let's see. 2 copper atoms on the left-hand side, 2 copper atoms on the right-hand side, 2 oxygen atoms on the left-hand side, and 2 oxygen atoms on the right-hand side. So the equation does balance. So now how do we then write it as a word equation? We are saying copper must react with oxygen to form copper oxide. There we go. So our last question, as you can see, it's a bit complicated because we're not given anything. All we are told is that zinc is going to react with oxygen. So we need to fill in the entire information from this table or on this table. So the word equation for this reaction will then be zinc reacting with oxygen, reacting to form zinc oxide. Now, in terms of a picture of this particular reaction, we have zinc, 1 atom of zinc, that is going to react with, remember that oxygen, it is a diatomic molecule. It must be written as 2. Remember, oxygen must be written as 2. So that's why I have 2 circles that are chemically bonded together to show that it's O2. And they are shaded because they need to be different from the atoms of zinc. And then the product of this is going to be zinc oxide. So it's going to be zinc with the oxygen. Oxygen must be shaded. Now, by looking at this picture, we are seeing that the number of atoms, remember we know that in any chemical equation, they must be balanced to say that the reactants must be equal to the products. The number of atoms on the left-hand side must be equal to the number of atoms on the right-hand side. Looking at this picture, we are seeing that I have 1 zinc atom, 1 molecule of oxygen, but 2 oxygen atoms. Then here I have 1 zinc atom bonded with 1 oxygen atom. So there is an imbalance between the oxygens. So how do we then balance the oxygen? So to use pictures, let's see. If I add another zinc oxide here to shade the oxygen, that would now mean that I have 2 zinc atoms on the right-hand side. I have 2 oxygen atoms on the right-hand side, which now that takes care of that one. Because if you have 2 zinc atoms on the right-hand side, 2 oxygen atoms on the right-hand side, we still have 2 oxygen atoms on the left-hand side. So that is balanced. But the zinc is not balanced because I have 2 zinc atoms on the right-hand side, but on the left-hand side, I have 1 zinc atom. So what do I need to do? I need to add another zinc. So I need to add another zinc atom on the left-hand side. So left-hand side, 2 zinc atoms, that's fine. Right-hand side, 2 zinc atoms, that's fine. Then here on the left-hand side again, oxygen, there's 2 atoms of oxygen, fine. And right-hand side, 2 atoms of oxygen, that's fine. So now what does this picture tell us? It tells us that we have two zinc molecules or 2 zinc atoms plus 1 molecule of oxygen that are going to react to form 2 molecules of the zinc oxide. So in terms of a chemical equation, in terms of a chemical symbol, how does it look like? So now we know that zinc has the chemical symbol of Zn plus. Oxygen, remember diatomic molecule, must be written as O2. And then the product is going to be zinc oxide, ZnO. And again, the problem that we faced initially of the imbalance, it still comes here. But we have taken care of that already because we said in order for us to balance, we need to have 2 molecules of the zinc oxide and 1 molecule of the oxygen reacting with 2 zinc atoms. So now you're seeing that we have 2 zinc atoms, 2 zinc atoms. And remember that these 2 goes for everything in this compound. So we also have 2 oxygen atoms and 2 oxygen atoms on the left-hand side. So our equation is balanced. So our equation does balance. So learners, remember, the reaction between a metal and oxygen is going to give us our metal oxide. There is a difference in ratio when the metal comes either from group 1 elements or group 2 elements. But there will always be a metal oxide, just a different ratio. Now, with all of that said, we are going to quickly take an ad break, and I'll see you just after this.